Okay, so last time we talked about polynomial functions. We talked about lots of different things. Okay, first of all, we talked about what is a polynomial function. It's a function that has positive whole number exponents. We gave some examples of that. We talked about the degree. The degree is the highest exponent in the function. We looked at end behavior. The degree tells us about the end behavior. We have two options for the degree. It's either an even number or an odd number. Even number, the arrows go together, both up, both down. Odd number, the arrows go opposite directions, one up, one down. And then the way we tell which way they go, up or down or positive or negative, is based on your leading coefficient, the number in front of your highest degree term. If it's a positive leading coefficient, I have to sneeze. An even degree, they both go up. If it's positive leading coefficient and odd degree, it falls to the left, rises to the right. Negative leading coefficient and even degree, they both go down. Negative leading coefficient, odd degree, it rises to the left, falls to the right. Okay, so we can look at any function and describe the end behavior just by looking at the first term. For example, on this one, odd degree, negative leading coefficient, it's going to rise on the left, fall on the right. For this one, we had to think about if I multiplied it all out, this would be like x to the third times x times -4, which would be -4x to the fourth. That's an even degree, negative leading coefficient, falls to the left, falls to the right, both going down. Okay. Another thing the degree tells us is the number of solutions. And we talked about solutions are exactly the same thing as x-intercepts, which are exactly the same thing as zeros, which are exactly the same thing as roots. They are all the same thing, just have different names for them. And the degree tells us how many solutions we have total. It also tells us the maximum number of turns. It's the degree minus 1. So the way we find the x-intercepts is we plug in 0 for y, solve for x, and we are solving for x by, as of today, just factoring. And in the future, there will be other ways to solve for x. So the last thing we talked about, and this is a super duper important concept, is multiplicity. So the idea of this problem right here, there are 4 solutions. When we solve it, we only get 0 and 2 as a solution. And the reason why we only get 2 answers here is because 0 is the answer 2 times, 2 is the answer 2 times. So the multiplicity tells you how many times something is an answer. Sorry. Okay, so how many times something is an answer? How many times is 0 an answer? It's an answer 2 times, so it has a multiplicity of 2. How many times is 2 an answer? It is an answer 2 times, so it is a multiplicity of 2. It could be a multiplicity of 3, 5, just depends on the problem. Okay, the multiplicity tells us what the graph does at that x-intercept. If it's an even multiplicity, the graph touches and turns at that x-intercept. If it's an odd multiplicity, it crosses the x-axis at that x-intercept. Okay, and we took that problem and we graphed it. We knew it had intercept at 0, it had an intercept at 2. We knew it touched and turned on both of those, and since it was even degree, negative leading coefficient, we knew it went down. So that tells us that our graph looks something like that. Okay, so we are going to spend more time graphing this. Okay, so the idea for graphing, like your thought process to graph it. The first thing we need to do is determine the end behavior. Again, how do we find end behavior? Remember how to find end behavior? Yep, you use the degree and you use the leading coefficient. If its degree is even or odd, leading coefficient is positive or negative, tells us the end behavior. The next thing you do is find and graph your x-intercepts. As of now, the way we're finding them is just factoring them. Starting next week, we will find them other ways for the problems that don't factor. But when we graph the x-intercepts, it tells us some information based on multiplicity. So just remember, just a reminder to use the multiplicity to graph it. Does it touch and turn, or does it cross through? Sometimes that is enough to graph a function. Sometimes we need a few more points. Some ways to get another point. What's an easy point to find from your equation? Say again? Yeah, y-intercept is really easy to find. Why is the y-intercept easy to find? How do you find it? Yeah, plug in 0 for x. Okay, if for some reason this is not enough points, you could always find more points. How could you find more points to graph? Yeah, plug in x values. If I need some more points around x equals 1 and 2, plug in x equals 1 and 2, okay? So I'm just gonna put plug in needed x values. This problem that we just graphed, this would be an example where you might need to find one more x value. If I went to go graph the y-intercept, where's the y-intercept at? 0, 0, it's already on there, right? So if I graph the y-intercept, it wouldn't give me more points. It may be beneficial to find where x equals 1. So you could plug in x equals 1 into your equation and get out a y value and know exactly, like, does this dip way far down? Is it just barely a dip? Like, you don't really know. You know, it dips somewhere. I just don't know how much it dips. So finding that specific value, which we can do real fast. Let's find the problem for it. Here we go. If I plugged in x equals 1, this would be -1 plus 4 minus 4, which would be -1. That didn't take but a minute, or not even a minute to do. Okay, so we know that it would dip down to -1 there. And that graph would look totally different. Say we got out x equals -10. That would be like dipping really far down, right? Okay, so let's put it all together and let's do a few problems. That's our focus for today, is putting this all together for now and doing some problems. Okay, so we are going to graph the problem. I don't even know what number we're on. I think it's number 3. We're going to graph the problem f of x equals x to the 4th minus 2x squared plus 1. First thing, let's find end behavior. To find end behavior, what do we need? Degree and leading coefficient. Is the degree even here, or is the degree odd? Even. The degree is 4, which is an even number. What's your leading coefficient? 1. And is 1 a positive or negative number? Positive. So what does even positive in behavior look like? Both up. Okay, so our end behavior looks like this. Rises on the left, rises on the right. The next thing we need to do is find zeros, find x-intercepts, find roots, find solutions. How do I find x-intercepts? Yeah, I'm gonna plug in 0 for y, solve for x, and the way I solve for x is by factoring for now. So 0 equals x to the 4th minus 2x squared plus 1. How am I gonna factor that? Yeah, you could just do AC method. You could also kind of do substitution here if the x to the 4th and x squared bothers you. You could say, like, my a value is x squared and plug in a, and you'd have a squared minus 2a plus 1 or something like that. Feel free to do that. Or you could just do AC method here. AC method is a is 1, c is 1. So AC is 1. What things multiply to give me 1? Yeah, 1 and 1. In this case, it has to be -1, -1 to get -2. Right? And this is like a shortcut problem. So normally for the shortcut problems, I would just write x minus 1, x minus 1. I can't really do that here, right? Because how am I going to get x to the fourth and x squared? It needs to be x squared minus 1, x squared minus 1. That equals 0. How do I solve for x now? Set your factors equal to 0 and solve. So I get x squared minus 1 equals 0. X squared minus 1 equals 0. Am I going to have some multiplicity here? Yes. So it's going to be the same thing on both of them. When I solve for x, add 1 to both sides. I get x squared equals 1. How do I solve for x? Square root. Don't forget your plus or minus. So I get x equals plus or minus 1. So you can think about that as x equals positive 1 and x equals negative 1. When I solve the other one, what am I going to get? The exact same thing, because it's the exact same problem. So I'm also going to get positive 1 and negative 1. So how many solutions should I have here? 4 solutions, because the degree is 4. I have 4 right here, but 2 of them are the same twice, right? So I have x equals 1 with a multiplicity of 2. I also have x equals negative 1 with a multiplicity of 2. Multiplicity of 2 tells me something. Is that even multiplicity or odd? Even. So even multiplicity touches and turns on both of them. So both of them bounce off the x-axis. Okay, let's go ahead and find the y-intercept, and then we will graph it and see if we need any more points, or try to graph it. How do I find the y-intercept? Plane 0 for x, solve for y. All right, so x equals 0, so this becomes f of 0 equals 0 to the fourth minus 2 times 0 squared plus 1, which is going to be 1. So that's the order pair 0, 1. Okay, let's go ahead. We actually don't have to do this, but this would be on your test and on your quiz. What's the maximum number of turns here? Yeah, remember it's degree minus 1, which would be 4 minus 1, which is 3. So it can't have more than 3 turns here. Okay, so when I go to graph it, I know my end behavior is positive, even, so it's going to go up on both sides. I don't know exactly where at, but it's going to go somewhere up on both sides. Okay, my x-intercepts, I have an x-intercept at -1 and at +1. So I'm going to have a dot there and a dot there. Is it going to cross through my x-axis, or is it going to bounce off? Bounce off, based on your end behavior, is going to bounce up or bounce down? Bounce up, right? And you can go and put your y-intercept on there. Where's the y-intercept at? 0, 1, right? So if this is 1 right here, that tells me exactly what it's going to look like. It's going to look like a W, right? So make it a curve instead of a, oh, I didn't do a very good job, but you get the idea. Don't make it jagged W, make it a curve. That's, it would look more like this. And you can kind of check, does this follow the maximum number of turns? How many turns do I have here? 1, 2, 3. Yeah, that's the maximum I can have. I can't have any more than that. Questions about that? Let's do another one. about if I had the problem, this is a good one, f of x equals -2 times x minus 1 squared times x plus 2. Okay, remember back when we were doing quadratics, we had two different forms. We had like a general form and like a standard form. Standard form was considered like vertex form. You could see the vertex on it. This is similar to the idea of vertex form. I mean, you don't really have a vertex for polynomials, but the idea here is it's not all multiplied out. Okay, we don't really want to have to multiply it out because it would take a really, really long time if you did multiply it out. So we're going to see if we can work with it and get all the things we need to know based off of that. Okay, so what's the first thing you have to find out to be able to graph it? In behavior. In behavior is the degree and the leading coefficient, which can be kind of difficult whenever it's written like this. The degree and the leading coefficient come from the very first term when it's all multiplied out. To find the very first term when it's all multiplied out, you multiply the number in front times the x to whatever power times the x to whatever power. Okay, so the number out front here is -2 times this x, the power on the outside is squared, so it would be x squared, times this x, what's the power on the outside here? Technically it's a first power, so it would just be times x. And what's -2 times x squared times x? To the third, because 2 plus 1 would be giving 3, so -2x to the third. So what's the degree for that one? Yeah, the degree here is 3, which is odd. What's the leading coefficient here? -2, which is a negative number. So odd negative, what is in behavior for odd negative? Odd means it goes opposite direction. Negative means it's like negative slope or decreasing. So it needs to rise to the left, fall to the right. Okay, so that's the in behavior. Now we need to find x-intercepts. When it's written like this, the x-intercepts are super easy to find because it's already factored for you, right? If you needed to, you could write this as, again, you plug in 0 for y, solve for x, so 0 equals, you could write this as x minus 1 squared is the same thing as x minus 1 times x minus 1 times x plus 2. It's already factored for you, right? How do you solve your factors? Set them equal to 0 and solve. This -2, do I have to set that equal to 0 and solve it? No, because it's a constant, it's coefficient. You could technically divide it if you wanted to get rid of it, but you don't have to do that one. Only the ones with x. If that was -2x, you would need to do that. Okay, so I'm just going to do x minus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0. When I solve for x, I'm going to add 1 and get x equals 1. Do it again, get x equals 1, subtract 2, get x equals -2. How many solutions should I have here? 3, because my degree is 3. Do I have 3 here? Yes, one of them has multiplicity though, because x equals 1 2 times, so it has a multiplicity of 2. Even number multiplicity tells me that it does 2 things. It touches and turns. It bounces off the x-axis. So touches and turns here. The other one, x equals -2. What's the multiplicity of that one? 1. Multiplicity of 1 is what? 1 an odd number or an even number? It's an odd number, so it just crosses the x-axis. Okay, so I'm gonna put that on my graph. I also need a y-intercept. How do I find a y-intercept? Plug in x equals 0. So it's gonna be f of 0 equals -2 times 0 minus 1 squared times 0 plus 2. So let's work that out. -1 squared is +1 times 2 is -4. So that's the ordered pair 0, -4. And what's the max number of turns here? Degree minus 1. Degree is 3 minus 1. So, because it was -2x to the third. Okay, so let's graph this now. Okay, my end behavior says on the left-hand side it rises, on the right-hand side it falls. So I know that over here somewhere in the second quadrant it's going to have an arrow going up. Down here in the fourth quadrant it's going to have an arrow going down. I also have x-intercepts, x-intercept of 1. So at 1, I have a dot, and it's going to touch and turn that. I don't know if it touches and turns up or down. I mean, technically you do. But, well, keep on going. Because technically, depending if I had an x-intercept after that, it could do something different. The other one, though, is -2. So at -2, I have a dot there. It's going to cross through that one, right? So it's going to go actually all the way through there. And then I also have a y-intercept of -4. So 1, 2, 3, 4. That's my y-intercept. Can you kind of see what this graph does? It's almost like we're putting like, not that we're putting dotted lines, but it's like we're putting things so that we can like trace it all together essentially. Real fast, if you wanted to, you could go ahead and get this dot right here too. This would be at f of -1, and you could plug that in your function. -2 times -1 minus 1 squared times -1 plus 2, which would be, let's see, that would be 1. -2 squared is +4. 4 times -2 is -8. Okay, so it actually goes down pretty low there. Like way down here. I'm out of paper, but you get the idea, right? Way down there at -8. So when you go to graph it, I know it's going, I can go like this. I know it's going to go cross through here. It's going to come way far down and come way back up. This isn't looking great so far, but you get the idea. It's going to come way down, way back up. At 1, what's going to happen? It's going to bounce off of it and go back down, because at 1, it had a multiplicity of 2, which means it touches and turns. So it's going to bounce off of it and come back down. And that's what makes this fall on the right. If it didn't bounce off of that, it would not fall on the right. Questions about that? And you could check that on your calculator. You could put that function in your calculator. Okay, we're gonna do one more of those actually, and then we will stop for the day. I'll do it. Okay, so if I had the function f of x equals 3 times x plus 1 to the third power times x minus 2 to the second power. I want you to take about 3 or 4 minutes and see if you can get in behavior, x-intercepts, and y-intercepts. So get started on it, and then we'll go over it together. For the first part, for the degree, did you get 5 for your degree? And your leading coefficient is 3. So that's odd positive, which would look like this. Falls on the left, rises on the right. Okay, for x-intercepts, if you write them all out, we get x plus 1, x plus 1, x plus 1, x minus 2, x minus 2. You don't really need to solve every single one of them. You just need to solve x plus 1 and x minus 2. When you solve x plus 1, you get x equals -1. What's that multiplicity? Multiplicity of 3. Since it has multiplicity of 3, that is an odd number. Does that mean it touches and turns or crosses? Crosses. So it's going to cross the x-axis at the x value of -1. Okay, and then x minus 2 equals 0. We're going to add 2 to both sides, and we get x equals 2. What's the multiplicity there? 2. Yeah, there are 2 of those here. So it has a multiplicity of 2. Is that an even multiplicity or an odd multiplicity? Even. So it's going to touch and turn. Okay, last thing we're going to do is find the y-intercept. How do you find the y-intercept? Yeah, plug in 0 for x, right? F of 0 equals 3 times 0 plus 1 to the 3rd power times 0 minus 2 squared, which is going to be 3 times 1 times -2 squared is +4, which is going to be 12. Okay, now that you have all that, see if you can graph it, if you haven't already. I'm going to give you like 1 minute to try to graph it, because sometimes that's the hardest part, is taking all of this and putting it on a graph. Okay, so at -1, it crosses. Usually if it crosses, I just put like a kind of a straight line through it because it tells me that it goes all the way through, and then the other one's going to bounce off of it. So this one needs to go down to -infinity. It's going to come up, touch your x-intercept, come back down, bounce off of that, and then come back up over here somewhere. It may be a little more like this probably, actually, but you get the idea. If you put that on your calculator, that one might be a little bit more difficult to see on your calculator because you might have to zoom out a little bit because the y-intercept is 12. And usually on most calculators, your view is set like a 10 by 10, actually 20 by 20, because it goes -10, +10, -10, +10. So I'm going to put this one in 3 times x plus 1 to the 3rd power, no, times x minus 2 squared. So if I zoom out a little bit, it's kind of harder to see, but you can kind of see it goes up, comes back down, pops back up. Okay, questions about that at all? Okay, next time we are going to learn how to divide polynomials with long division and synthetic division, and we use that to be able to solve them when they're not factored for us or they're not factorable. So I have 2 things for you to remind you about though. Just a reminder, you need to do your comp attempt number 2. If you're not already finished with that, or if you are not happy with that grade, remember the password is ready2, and it is available now until Monday night at midnight to take it. The other thing is I have a little project for you. This is going to be due on Wednesday. So we're going to say project number 1. This is due Wednesday, which is October 7th, 10/7. Okay, this project for those of y'all on Zoom is posted on D2L under week 6 documents. There's a front and a back to it. Okay, it's piecewise function stuff. And then also this is the arithmetic and geometry series. So it's kind of older stuff, but this stuff is on your final exam. So that's why we're going over it now still. Okay, so again, that's due on Wednesday, October 7th. If you're on Zoom, make sure you go on D2L to get it, and I will see y'all on Monday. Have a good weekend.